Now look at another criterion for model selection, and this is MallowsCp. Colin Mallows was a researcher whom I met early in my career, late in his career at AT&T Labs. He is in New Jersey and has a little farm because he likes being a part-time farmer. And his biggest hobby is playing ping pong. And he was for a long time the second best ping pong player in New Jersey of his age group. Yes, so little side story. I don't know what the status is right now. Maybe he's the best now. I don't know. So suppose a submodel under consideration contains k variables, and k is smaller than p, of course, because p is the total number of variables. Then Colin Mallows proposed this statistics. We divide SSE with the k variables by sigma squared of the full model. And we penalize this ratio by adding a term here. You're trying to minimize CP. And so if you add something here, then you're penalizing, right? So we can rewrite the SSE as the sigma squared corresponding to the k variable model. And to compensate, we have to multiply something in here. And now Colin Mallows said that, well, if the k variable model is pretty much as good as the full model, then these two things should approximately be the same and therefore cancel out. Once they cancel out, we can finish the calculation here with the remaining terms, and we get k plus 1. So if the k variable model achieves roughly the same sigma squared as the full model, then the statistic should be k plus 1, approximately. So we have to remember it's easy to confuse k with p, right? K is the number of variables in the submodel, p is the number of variables in the full model. If there are several good models, take the one with the fewest variables, smallest k. And the acceptable models are those that are smaller or approximately equal. So that means it can be a little bit bigger. It's an approximate sign, right? So if CP is, let's say, 15.3 and K is 14, then you are 15.3 and 15. The equal sign still holds here, where the approximate sign still holds, right? So you have to, well, that part is a little bit non-exact, let's say that one. So here we have the table again with the best two models based on the CP criterion. And my question again for you is, which model is best based on this CP criterion, right? So you're trying to look at acceptable models, and among the acceptable models, pick the one with the smallest k. All right. And as before, for completeness, here's the R code that generated this table.